Hopefully this will work. Okay, so we're actually managing to stream live, I think. All right, well, I guess we can dispense with most of the introductions. There's a few people in the class I haven't met before, but by and large, I know everybody. I remember probably 9 out of 10 names, so you may have to excuse me if I ask you to remind me your name, but I know most of them. Okay, so let's just jump right into plan for the course. So you can find that on Blackboard under course info. Usually when I create the syllabus, I wind up having to make many versions of it because we update it. So I already realized this morning I had to make another change. So if you grabbed it yesterday, there's already a small change on it. So although the class title is mobile, for a couple reasons, we're going to focus strictly on doing Android development. The biggest reason for this is doing iOS development is very environment dependent. We'd have to have the class in a Mac lab, and there's only one Mac lab on campus. And unless you have a Mac, you're not going to be able to do iOS development and compile things off campus. Android platform independent, so solves that problem, right? We can just run Android anywhere, run it on our laptops. One of the other benefits of us using Android is you guys have done a lot of Java. Now we're actually not going to use Java in this class, but yes, that's a very confused look on your face. I'll explain why in a minute, Vlad. But you have the coding background that you need. If we were going to do iOS, then we're probably into something like Swift, which is an entirely new language altogether, new framework. So if we stick with Android, we can actually go a lot farther, do a lot more. One of the other nice benefits of Android development is it's cheaper for us to publish our apps to the Google Play Store. So Google charges, actually, does anybody know what Google charges? Yeah, $25 US as a lifetime fee. Once you pay that fee, you can publish any apps to the Play Store unlimited. Anybody know what Apple charges for the App Store? Avi? 100 a year, US, right? So it's going to be much more expensive for us to publish to the App Store. So I think we're just going to stick with Android. There are also some cross-platform frameworks. A lot of those are kind of web-based tools and JavaScript-based, but again, in order to be able to compile them for Apple, we still need access to Mac OS, and we still need to pay the App Store $99 fee if we want to be able to publish. So I'm mindful it's not cheap to be a student. So I thought for those reasons, we're going to stick with Android for this class. Okay? And also, how many people here have an actual Android phone? Yeah, typically it's the majority. Now, there is an emulator that comes with Android Studio, so you don't actually have to have a physical device, but one of the things I might recommend is bring a USB cable for your phone to class if you have an Android device. So if you want to actually plug your device in, you do have the option as you're coding to run your app on an actual device, if you like. So feel free to bring one to class. I know the last time I taught the class, there were 1 or 2 students who found the emulator was super slow on their computer, and they said, it's just faster. I just prefer to plug my phone or my tablet in and run my code on my device. So you got the options to do that. This was the thing I actually had to change. So my schedule got changed yesterday. So if you grabbed the syllabus earlier, the office hours would have been different. So I'll have office hours right after class on Wednesdays, which is kind of a convenient time to come and see me. Also on Tuesdays, I have a couple hours from 11 until 1. Okay. I can also often be available Mondays or Thursdays. We just have to book an appointment. Okay? So these time slots, if you want a 15-minute time slot, just use the Calendly link and book a 15-minute slot. Okay? All I ask is the first few weeks of school, no one's ever in office hours, and then when assignments and things start being due, there's a lot of people who want to come. So I just have a couple requests, just a reminder. I know you've kind of been through this before. If you want to come and meet me during office hours, please book one appointment. Like, don't book a block of them. It's not fair to other people because there's kind of limited time. The other thing I ask is just come with what you want us to look at kind of ready so we can make the best use of the time. Okay? And the last thing, this was a bit of an issue the last semester. I understand you may book an appointment because you need help with something, and then you figure it out before your appointment and you don't need to come. If you do, can you just delete the appointment request? Because otherwise you've blocked the time off, and I had some instances last year where I had a lot of students asking for help, and some students booked appointments, then didn't come, and other students didn't get appointments, and they could have taken that time. So please just make sure you cancel an appointment if you can't show up. Okay. We're going to do a lot in this class, and I know it's new technology. So yes, even though I record the lessons, you'll get the most out of the class if you're here. I know it's not a great time. 8 a.m. isn't my favorite time of day either. It's your only class today for most of you. It's my only class. We may as well make the most of the 3 hours we have. Okay, so you're gonna get the most out of it if you're here and can ask questions. I know looking around the room that generally attendance with this group is really good. You guys are paying for the class, you may as well get your money's worth out of it. Okay. If you're struggling, please ask for help. Okay, everybody's in their third year, right? You've all finished 2 years. So I know everybody's capable of learning and succeeding at college. You wouldn't have made it into this class if you couldn't, right? You already had the option to get your diploma and you chose to come back. So just make sure if you need help that you ask for it. Here's the breakdown of the grades, okay? So the 3 assignments, it will be one large project. Okay, and I haven't quite decided yet whether the project will be an app that you choose to build yourself, or I'm working on potentially having a client. That's somebody who actually wants an app built and will describe the requirements and come in and will basically build something for somebody else. I've had a few discussions with some faculty in some other areas about some ideas they might have for apps, so if I can manage to do that, we'll know in the next few weeks. And the assignment will probably be, depending on the scale of it, probably not an individual assignment. So you'll probably have the option to work with at least one other person on it. Midterm and final in week 7 and 14. This class is weighted more heavily towards the assignment, so you notice the test grades are not that heavy. Even the final exam's only 15%. And those will probably be open book practical exams. That's kind of my preferred method of testing, as you know, rather than just asking you to answer questions. We'll have a couple of quizzes. We're not going to have quizzes every week. Okay, we'll probably have a few sprinkled through the semester, maybe every 3 or 4 weeks, just as a bit of a review. And labs, if we have, again, probably only a couple at the most. Okay, so the focus really will be on. So these assignments will be related. Assignment 1 is basically going to be your plan for the app you're going to build. Okay, maybe some mock-ups, a description of how it's going to work, database schema. Whoops, and the weighting for this is wrong. Yeah, I knew it would be. So assignment 2 will basically be a beta version. So a partly complete version of the app. And then assignment 3 is going to be the complete version that you are going to have to publish to the Google Play Store. So yes, it will mean you will need to pay Google that $25 fee. On the plus side, no textbook costs in the course. Okay, $25 to Google is probably less than what a book would cost you. Okay. And again, the reason I tend to shy away from books is by the time they're published and shipped and you can buy them, they're out of date, really. So we're just going to kind of stick with online resources as opposed to a textbook. You do need to earn a 50. Okay, I won't hand them out. If you get a 45, you've probably earned a 45. There are no makeup assignments on offer, unfortunately. Okay, so these are all your chances to earn grades. So just make sure you do all the work, submit it all on time, maximize your chance. I'm really not too worried looking around the room at this group that this should be a big problem. So we'll make the assignments due on Tuesdays at 5 o'clock before you come in. So you're not working all night on it Tuesday night before having to come in. And late policy is 20% per day. So if I get something on a Wednesday, you lose 20% off the top for it. Okay? That said, if you have an emergency, an illness, please let me know as soon as you can. Something that, legitimate circumstance out of your control that's going to affect your ability to submit something on time. Please send me an email or come talk to me and we'll work out some kind of reasonable arrangement. Okay? I'm not an unreasonable person. And this stuff, I think you already know, I'm really strict on it, okay? A little less of a problem in group projects, but unless I say you can work with somebody else, I expect you to do your own work, okay? If you take code off, if you find code in a tutorial or somewhere else, make sure you cite it and or you just check with me that it's okay to use in your assignment. So penalties for a first academic misconduct is 0 in the assignment. If you've had one before, the second penalty is a 0 in the course, and the third one is dismissal from the college. So I will check your code. If something doesn't look right to me, if you've given me code that I'm questioning where this came from or it looks like somebody else's, then your assignments are subject to a code review, where I'll ask you to come in and say, explain this to me. How does this work? If it's in your project, you should be able to explain it. And if it looks exactly like someone else's or exactly like something I found on the internet, I'll ask you to explain it. Here's our, let's see. I have it somewhere. It's the first day, so I need to do this. Just before I move on to the schedule. Okay. I'll have to find out later. Never mind. We'll move on to the schedule. So here's our fairly rough plan. Okay, fortunately, class is on a Wednesday, so we don't miss any lessons like we would on a Monday. So the labs and quizzes will kind of be sprinkled through the remaining weeks. And subject to change a little bit, some of these lessons may take a little longer than I planned, some may be a little shorter. So we can plan, so the main assignment will be due in the second last week of class, and that'll include a demo. So you'll have to basically, that class, rather than there being new content from me, that class will basically be you seeing each other's apps, okay? If we have a third-party client, then I'll invite them to class as well to come and see what work you guys have done. We should be able to, for the most part, stick to this, but again, there'll be a little bit of flexibility built in here. Anybody have any questions about kind of our plan for the term? No, it will include lots of logic and coding, but we're not going to use Java. And I'll explain we're going to do something different, and we'll get into that shortly. So this is my second time teaching the class. When I taught it before, I did use Java, but I know you guys have already done how many Java courses? 3 already? Okay, so that's a fair bit. And for various reasons, which we can talk about, we're going to use an alternative to Java. Anybody else have any questions with class? One thing we should probably talk about together is what you'd like to do about breaks in the class. I have an opinion, but I'm pretty flexible. I'm happy to let you guys take a vote on whether you'd like to do 50 minutes on class, 10-minute break, another 50 minutes of class and a 10-minute break, or whether you'd prefer 75 minutes or so of class and a larger break, like sometime around. Okay, if you would prefer 2 breaks, can you wave your hand in the air? 1, 2, 3, 4, 5, 6, 7, 8, 9. If you would prefer 1 break. Okay, we may have to put, that's pretty even, we may have to put it as a Blackboard poll so we can. I'm of 2 minds about it. On the one hand, 2 breaks, given where the geography of where our classroom is, if you want to go get food or coffee, 10 minutes isn't very much time. For you just to walk over there and walk back is going to take you to 10 minutes. So the one danger with the short break, at the same time, I realize the class is early in the morning and asking people to kind of stay focused from 8 o'clock till like 9:10, 9:15 isn't the easiest thing. I'll put up a quick poll on Blackboard and we can maybe vote there. Just give me a second. I may even have a poll here I can reuse. If not, I'll just throw it up. Is Blackboard this slow for everybody else or just me? Yeah, this is really bad. Okay, so put it in this way because it's asking me for a yes or no. So the question will just be, I want 1 break. So just hang on, it'll be available in the assignments tab in just a second. Okay, I think if you refresh the assignments tab, once this finishes posting. Okay, it should be there. Oh. Sorry. It's there? Okay, so why don't you have a quick vote. And the winner is one break. So we'll maybe take that break roughly about 10 after 9. Okay. From here, actually, if you need coffee, it's probably faster to go across to M Building, go to the Tim Hortons there than it is to walk all the way back to C. It's probably closer. All right. So I'm wondering if the issue is not Blackboard, but this encoding software that I'm using for the stream, that might actually be what's slowing me down. So as usual, I'll put all our in-class stuff on GitHub at the end of every class. I actually have to update this link as well for the playlist. Some resources here for you. Okay. So the main developer page, this is useful. Those are the official docs from Google. So we'll probably look in there a lot. We're going to use this service later on. So we're going to use, I know you guys have used, you probably used MongoDB in your JavaScript class. Who taught that class? Was it Sean or Chris? Chris? Yeah, Sean? Some of both? Okay. So we're going to use a different cloud NoSQL database. We're going to use Firebase, which is actually a Google product. So obviously it integrates really easily into Android. You may want this program, you may not. This is a third-party Android emulator. It's basically a plugin you can add to Android Studio. So some people prefer it to the built-in emulator. And then later on, we'll look at these things in terms of design, some of the material design resources that Google makes available for us. We'll get into those. Not sure we'll need some of these. And as usual, if you need, there are your 5 Git commands. If you forget, hey, how do I get my stuff on, how do I create a new repository and get my stuff up on GitHub? There you go. Okay, so that's always here as a reference for you down at the bottom. So today what we're going to do, we're not going to do anything too in-depth. We just kind of want to do things that are really high level. So first of all, let's talk about, I mean, we've talked a little bit of some of the practical reasons about why we're going to use Android for the course. These are some pretty current numbers. Anybody want to take a guess? What percentage of users globally use Android as their mobile OS? What do you think? 65? 80? I say 80? All right, let's have a look. Sorry, we haven't met. I don't know your name. Michael. Let's have a look. I think these stats should be fairly up to date. I did just have a look at them. So this is this is August to August globally. Now this is globally. If we look, for example, in North America, I believe it's much closer. Wealthier regions of the world, we're going to see a lot more iOS and a lot less of it. Yeah, so pretty much bang on even in North America. But that just means outside of North America, Android is even more dominant. Curiosity. I would bet in Asia, iOS is much lower. Yeah, even lower than globally, only 12%. So what can we run Android on? What kinds of devices will run it? Sorry? Yep. Mm-hmm. What else will run Android? Yep. So, for example, you mean like a TV box, like an Android TV? Yep. What else can you run Android on? Yep, Android Auto in your car. Yep, watch. Yep, your fridge. Yeah, your thermostat. Right? Almost anything you will have played with in your Internet of Things course. So as the Internet of Things grows and grows and grows, more and more knowing how to work with Android device is going to be useful. Right? The demand for that is just going to be massive and is going to continue to get massive. So this is a couple of years old, but kind of gives you an overview. So Android's been around for a while. So 2003, so it's a pretty mature operating system. And over 2 million apps in the Play Store as of 2016. Obviously, that number's a lot higher now. And you can see from that kind of global market share just how dominant it really is, especially outside North America. So what we're going to do today is do a couple things. We're going to kind of, does everybody have Android Studio installed, first of all? Sort of. You're working on it, Ron? Okay, yeah. There will be lots of updates. So Android Studio, it used to be that usually people used NetBeans or Eclipse was kind of the default Android editor. And then when JetBrains came out with Android Studio, Google sort of adopted that as the primary IDE for Android development. It's not the only one, but it is the primary one. So we're going to do kind of two things today. We're going to play around with Android Studio and just kind of get a sense of playing in the UI. We're not going to write a lot of code today. So we want to play around in the UI, see what that looks like. And then we also want to talk about this, Kotlin. Does anybody know what Kotlin is? You got it, okay. So Vlad, coming back to your question from before, if we're not doing Java, what are we doing? We're going to use Kotlin. Okay. So Kotlin is a newer language. As Travis said, it makes things easier, okay. One of the, it has some neat features. Kotlin is completely interoperable with Java. So our Kotlin code files, they have a .kt extension, but we can actually write both Kotlin and Java in the same file if we want to. So in a way, Kotlin's almost a subset of Java, and it's interoperable. We can't write Kotlin in a Java file, but we can write Java in a Kotlin file. So there's a few reasons we're going to use it. So Kotlin was actually created a few years ago by JetBrains. They figured that they could come up with a more lightweight, faster, higher performing, easier to code language than Java, and obviously it's baked right into Android Studio because they made the IDE. When I taught this course last time, we used Java for the most part, and then we did 1 or 2 lessons at the end just as an introduction to Kotlin. And the reason why I've decided we're going to try to use Kotlin in this course is a couple reasons. One is feedback from that class. At the end of the term, when students did the faculty evaluation, probably one of the most common comments I got was, it actually would have been cool had we learned more Kotlin, right? We've learned lots. We know lots of Java. We know Java. We really didn't learn anything new language-wise from doing a 4th course in Java. You know, we're comfortable in Java. So rather than give us a 4th course in Java, we would have preferred to have done Kotlin right from the beginning. Right? So that's one reason, was based on student feedback. 2, this is definitely the direction that Google is going. So if we look in the official Android documentation, much like Microsoft used to do, where it would document all of its ASP.NET libraries in both C# and Visual and VB.NET. Eventually they phased VB.NET out. Google's starting to go this way. So if we look in the documentation, any code samples you find from the official docs, there will be a Kotlin tab and a Java tab. And probably more and more, we're going to see that this is kind of the future direction. So not only do we want to play around with kind of the UI components in Android Studio today, but we'll also want to get our feet wet with Kotlin. And we'll see that it is a much more lightweight syntax. So something that would take 100 characters of Java probably takes 50 characters of Kotlin. You guys already can put Java on your resume at the end of the class. It's something new you can add. So I'm just going to give kind of a quick overview. This isn't very long, just maybe 8 or 9 slides to give you an idea of Kotlin. And we'll play around with it in a bit. So it can actually compile either through the Java virtual machine or through JavaScript. Okay? It's open source and it's fully compatible not only with the native Java language, but any libraries and frameworks. So basically, when we create a new project in Android Studio, we have to choose whether we're building in Java or Kotlin. We pick Java, we get .java files. We pick Kotlin, we get .kt files. So the runtime is much smaller. It also supports a couple of other things. It has null type safety, so we get far fewer null pointer exception errors with Kotlin than we do in Java. It also supports the kind of asynchronous calls that you would have done in your JavaScript class, where we use Node for doing asynchronous callbacks. Okay, so Kotlin allows us to do this. If we want to start a process, let it run, and while it's running, we want to do something else. Our Kotlin code is going to support that easily. So here's, for example, how a Java call is going to get shortened. So you'll notice a couple of things. Well, what do you notice? Syntax-wise. Those are functionally equivalent. Yep, so we've got val, so that would be a JavaScript construct. Why do you suppose there's val here instead of string builder? So I mean, in JavaScript, val, our variables aren't typed, our objects aren't typed, but in Kotlin it is still strongly typed. Right, it infers the type, so we don't have to declare, right? And C# has gone this way as well. We don't have to explicitly declare variable types. We can just use val. The Kotlin compiler will interpret that. What else do we notice that's saving us a little bit of work? Yeah, we don't need new, and we don't need, right, we don't need semicolons. So it's taken me about 5 years to get used to the idea of putting semicolons in my code. Because then I learned to code. I did most of my apps using VB.NET, and now finally we can use another language where I don't have to put in my semicolons. Okay. So our syntax is just lighter. Yep. That's right. Won't break it, so if you want the semicolon, that's fine. You can go ahead and put it in, no problem. But it doesn't require it. So here's an example of a button click handler. I know that may be a little hard to see, gray. So in Java, first we would make a reference to, so we have this button. So there's an object in Android called a floating action button. Does anybody know what a floating action button looks like? Yeah, it's a circle with an icon, and where on the screen do you usually find it? It can go anywhere. Where's the most common place to see it? Yeah, the bottom right corner is typically where we would see a floating action button in Android. So if we wanted to write a click handler, first we would have to make a reference to it by finding that object in our user interface, and then we would create an on-click listener this way. And we'd also would need to override, and then where our dot is, this is where our code would actually go when that button is clicked. So that's kind of the style of Java that Android developers have been writing for years and years. Here we can just use val. We find the object, and we don't need the override, we don't need the outer wrapping around that event handler. So this is going to be shorter and faster to write, less prone to mistakes. One of the things that I find many developers find super annoying about Android development is for every screen we create in an app, we get two files. We get a layout file, which will have an XML extension, and then we have the code file, which will either be our Java file or now our Kotlin file. So they're tied together. But in order for us programmatically to reference any object in the user interface, we first have to make a reference to it with this find by ID. So if we have a whole lot of elements, let's say it's a registration form with 20 input boxes, we have to manually reference each one of those before we can access it programmatically. And Android has been this way for a long time, which wastes a lot of time. So Kotlin has, for example, a reference library that if we just import it into our project, we no longer have to programmatically reference every one of our user interface controls before we can access them programmatically. So we don't have to declare or instantiate them. So we'll want to use this library. It'll save us a bunch of time. So here are some of the current Android apps that are built using Kotlin. Obviously, these are names you probably recognize, which gives you an idea of what the adoption is going to be like. Right? When big corporate players start using the technology, it's a pretty good sign that others are going to follow. So if we want to add Kotlin even to an existing project, we've got a couple references here. They're basically as plugins. We've got the Kotlin Android plugin and the Kotlin Android extensions plugin. And that's going to allow us to then use Kotlin in our project. Without those, going to default basically to running Java. So syntax-wise, we'll play around with this a little bit. So we said we don't need our semicolons anymore. We don't have to override those event handlers, which was wasteful. We also have the fun keyword. Anybody have an idea what the fun keyword might be used for? Yeah, for functions. Okay. And then we've got val and var. So basically a val being a constant and a var being a standard variable that can change. We can also use it inside a Lambda expression. We may have a chance to play around with that a little bit later. So our code is going to be a lot lighter, and it takes a little while to get used to Kotlin, but the feedback I got from my last class was once students had played with it a little bit, they really liked it. And we always have the option. So my plan is we're going to use Kotlin all the way through the semester. Okay? If everybody hates it after a while and you prefer to go back to using Java, then that's fine, we can. Okay? But I think you'll probably like the benefits that it offers. Why write more code when we can write less? Why do something we've already done lots of when we can learn something new? But if you're finding you really, really don't like the language, let me know. All right, so let's fire up Android Studio. And we'll play around first just with some of the UI options. And then later we can play around with some Kotlin as well. So like all the other IntelliJ IDEs, it defaults and just open, by default it will open the last project you had. But we're going to create a new project. And there are a number of project templates available. Also, if you installed it, I think I sent out my announcement last week, so probably some of you installed it last week. There's already an update. When I opened mine yesterday, it already prompted me to update something. So I'm going to start a new project. And by default, I think the default directory where it will save is in Documents, Android Studio projects. That's the default location, which obviously you can change. So I'm going to start a new project. So here are all the templates. So you'll notice actually a bunch of tabs at the top. So these are, traditional mobile phone and tablet templates. And we're primarily going to focus on developing for phone and tablet. Fortunately, the way that the Android UI tools work is they allow us to build one UI that should generally scale fairly well between phone and tablet. We don't typically have to make too many separate UIs. We can, but generally things are designed to scale. So we do also have the option for wearables, for TV, for Android Auto, for Internet of Things, right? All the different devices that you guys touched on earlier. There are some templates here. So for phone and tablet, they've kind of given us templates for some of the most common layouts. Actually, we were talking about looking at the code sample with the floating action button. We're actually going to pick the empty activity, but you notice on the basic activity, it actually comes with the floating action button already there, which we could then change the color, change the icon, change the position, and then add an event handler on that button. We'll maybe play with that one another day. For now, I'm just going to pick an empty activity template. So we're just going to get one blank screen. And Android, they actually use, so you'll see, they use the keyword activity. They don't refer to forms or screens. In the Android world, those are called activities. So we'll pick an empty activity. Let's see. So I'm going to give it a name. And you'll notice here that it will automatically fill this package name. What does yours say here? So I've already signed in through my Google account. What does it say here for your package name? COM.example. Okay, so what the package name does is the Play Store will actually use that name as a unique name if you publish your app to the Play Store. So typically the way the package names are done is it's com dot and then you have a company name. So you could use your own name, you could use your student number. I would suggest taking out the word example and replacing it with some kind of personal identifier. And then it will be dot and it will it'll take the project name and generate that into an all lowercase with no spaces unique package name. So this is part of Google's way of making sure they don't get two packages with the exact same signature published to the Play Store. It's got to be a unique identifier. Now your language probably defaults to Java. So I'm going to ask you to change that drop down. Mine says Kotlin because the last project I did was Kotlin. It'll default to whatever you chose for your last project. So make sure you choose Kotlin. And then we get this drop down. This is a bit of an interesting one. The minimum API level. So mine defaults to API 23. And one of the neat things is Android Studio actually tells you if we run it for this Android version, this is the percentage of all Android devices that should be able to run the app. So if we pick, for example, something newer, we can pick Android 9 Plus, but nobody's actually going to be able to run that. If I plugged my own phone in, which is a couple years old, I couldn't actually run the app on the version of Android I have on my phone. So when we're in production, this is a fair question for us to think about, right? What API level are we targeting? Typically, it's probably a good idea to go with what Android Studio recommends. So I'll basically target Marshmallow, which will get about 2/3 of the Android devices in the market. You can play around with this. And then I'll just click Finish. So much like creating a new we can try it. It often causes problems. Technically, yes, you can change the API level because you may realize, oh, I picked the wrong one, or I need a feature that's available in a newer version, and this doesn't support it. So you can. The trick is, I'll show you in a minute what the challenge is. So technically, yes, but it's not simple. So much like just like when we're creating a new project in Visual Studio, an ASP.NET project, it's going to compile. So same thing. So Android uses a build system called Gradle. So as soon as you create the project, Gradle is running, and it's going to try and compile the project. Unfortunately, even for a tiny project, Gradle is not fast, as you can see. So we'll just have to let that run. Your IDE looks pretty much like any other IntelliJ IDE, like WebStorm or PHP Storm. Actually, one thing here, while Gradle's still running, we can look at. You notice over here, so this is our project view. This is not the way, if I expand my project, oh, I didn't create the project in the right place. Okay, I'll have to move it. Okay. I'm going to do that again and create my project in the right place this time. Bear with me for a second. I'll redo that. I'll pick an empty activity. I will make a folder for the project first. That probably would be a better idea. Did your Gradle sync finish, or is it still running? Finished? So this is, we have a little drop down here on the left in our project view. So this is not actually the way the project is stored on disk. Android gives us a few different views. They've given us this Android view because it's most useful as a developer to navigate within the project. If we want to see how it actually looks in our file system, if I change to the project view, this actually mirrors what we would see in our file explorer. So it actually looks like this, where almost everything is inside of the app folder, and then source, and then we get a test. We get 2 test projects as well as our main project. And even though I picked Kotlin, we get a Java file, and here's my main activity all the way down here. So it's kind of a little bit hard to navigate around this way. So most of the time, we're actually going to want to use the Android view instead. And we'll see what's here. Okay, my project is finally finished building successfully. So in here we have 2 views. We have our app code and then we have our compilation. Devon, and I'm going to come back to your question about the API view. So we've got 2 build files here. We have one at the project level and one, both are called build.gradle, so under Gradle scripts. So here's the issue. So our build.gradle, it lists both the minimum version, so any user, any Android version who has less than version 23 of the SDK won't be able to run our app. So that's the lowest that we're going to allow. And here on line 12 is we're actually targeting version 28, but we're basically backwards compatible to version 23. We can change these, but if we look down here, we have other libraries. So this is our UI library, and it references version 28. So if I change the minimum SDK version here, some of the other references may or may not break. So there's no guarantee if I want to go further back from 23 or ahead that all my other references aren't going to get ruined. You can try it, it may work, it may not. It just depends on the dependencies. And because we picked Kotlin, if we had picked Java, we would not have this dependency. Right? So here's our Kotlin dependency that allows us to write our code in Kotlin. So later on, and it applies these 2 plugins. So later on, there are other dependencies we're going to add here. So for example, when we want to integrate Firebase, so our app can use Google's cloud service, we're going to need a dependency here, several dependencies, so that we can talk to Firebase. So this is kind of our main application configuration file. We have a project level one here that talks about what version of the compiler are we using. We don't change things very much in this one, in the project level. Mostly it's at the app level. So let's also look at the structure here. So our configuration's kind of broken up among a few files. In terms of things like compilation and dependencies, the build.gradle is handling those things. We also have a manifest, which is an XML document. And this document sets up some basic properties of our app. So things like the app title, the actual icon that will appear for it, what the startup activity is. In this case, we have a main activity, that's the default activity. So that's going to be our launcher activity. When you first start the app, this is going to be the activity that loads. As well, it includes the package name for the Google Play Store. So later on, we'll configure some other options through here. So then, if I go down to my Java and my main activity, here's our class file. So this is where we could interact programmatically with the activity. So here's our fun keyword. We'll come back to this later. So every activity has an onCreate method that basically sets what is the name of the UI file that gets rendered in this activity. So remember, I said every activity has two parts. There's the Kotlin or Java class in the background, that's this file, and then there's a separate file that actually handles the UI. So that's this activity main. We find this one down here in our RES folder. So RES stands for resource. By default, we get 4 kinds of resources with our project. What do you suppose some of these are for? Looking at the names. Jonah? Sorry, these here are for unit testing. You're right, Jonah. So we've got unit testing projects here under the Java, yes. The resources are actually more UI based, but yes, you're right. Sorry, I wasn't clear. So those here are in green, those are the unit testing projects. We'll actually play around with one in a bit. What about drawable, layout, map, and values? What do you suppose any of those are? Yeah, so global variables we might store in values. If we expand it, you can actually see we've got colors, strings, and styles. So each of those actually has a XML file where we can add colors, styles, and the strings. The idea is generally Android discourages us from hard coding text into our user interface. Why do you suppose it would want it? So for example, text on a label or text on a heading. It actually wants us to put that text in a resource file instead for scalability. What would be the benefit of putting any hard-coded text in a separate file rather than embedding it directly in the UI? Jonah? Takes less space, yep. It acts as a property file, yep. Yep, that's true. If we have the same text throughout, we can just put it in the resource file. And probably the biggest reason, sorry? It's easier to change, but yeah, you're getting even warmer, right? Accessibility, particularly for multiple languages. Rather than hard coding our labels, our instructions right in the UI, it wants us to create a separate strings.xml for every language. So we would create subfolders with language codes. That way we can easily make our app available in multiple languages. So if we put a label on it in an activity and we hard code the text in, it will work, but Android Studio will give us a warning. And it'll say this text value should get moved to strings.xml instead. But that does make it much, much easier if we build an app in one language and then suddenly we've got a demand to translate it into another language. So colors, we've got 3 main colors. So these are the default, the primary, dark, light, but we can define our own colors here. And that's where that material design palette will come in. We can set up some styles. So again, the styles reads from the colors. Map is mostly to do with icons. Our drawables are for images. So we want to add images to the app. We store them in the drawables. And we have to be really careful that our images scale, right? Because everybody may be working at a different size device. Jonah? Yes, absolutely, right? So we want to make our own custom control images. They can go in there. And then finally, we have layout. This is actually, and we'll stop in a minute. I see a few yawns. I know you guys need coffee. That's okay. Here's our actual UI. So it's a .xml document, and we have 2 views of it. By default, we're in the design view. So on here by default, it gives us what it calls a text view. This is Android speak for a label. So a text view is just static text that the user can't change. And it's got hello world. Or we can look at the text view. So here is the XML rendering of this view. It's got a constraint layout, which we'll talk about. Constraint layout's too complicated to talk about before you guys have coffee, so we won't. And then here's our text view. So it sets out the properties of the layout with what it says, and then there are some constraints. So where is this positioned in the activity? So we can either modify this through the XML, or we can use the drag and drop designer. We probably will do a combination of both. Okay, so we're not going to get into running it yet because that'll involve making